Okay, I made it. Hi. Hi. Oh my God. There are people here. Sorry for keeping you waiting. I went and made coffee. That's why I'm late. Um, we have audio. Should we not have audio? Um, yeah, there was an issue, but it was something was pressing on the keyboard. That's why I kept clicking the wrong button. Hello, coffee, and hi, Said Sharikh. You need to tell me how to pronounce your name one day. And is Liske a new chatter? What's up? Thank you. I wish you a good day as well. Yeah, we made it. I'm here. Yes, I started a bit late today as well. Life, sometimes makes you feel like not wanting to get up early in the morning and you become lazy, and that happens. And that was me today. But then I remembered. I was like, you know what, half an hour is fine. But then I was like, no, no more than that. Huh. I see. Yesterday I made the voice lower when I was doing the BRB, and I forgot to make it higher. See, I can show you. So now it's low, and then I crank it up, and now voice is back. Yes. All right. So is the glass too much? It was like it matches the. I am see-through right now. The cloth has a green thing, but now it looks see-through. Oh well. At least you can see the panda. Are my eyes see-through? Let's see. Less so, but at least, yeah. You can see my eyes through me. That's fun. Right. Key. So, I was just about to answer your previous chat where it was like I shall endeavor to derail yesterday. Oh, hi.
C03CAF3 just redeemed change glasses.
Yeah, I actually added that, I don't know when, a while back. All right, we can change glasses. Let's go to the place where glasses gets changed. I think you will see it actually. Should we go here so that I can have you choose one? Eyewear. Where? Oh, you can't? Can't see it? I thought you could though. I can't make it go high. And I think, yeah, no, I can't. Okay. I can do Harry Potter glasses. I can do square glasses. What's happening? Oh, it's fine. No. No, I was just, I'm now thinking. Should we do Harry Potter glasses? For some reason, I don't like the Harry Potter glasses. They're too round. Actually, it's cute. Pretty cute. I hate to use them because it seems like bothering you. No, not. Might be nice if your glasses aren't showing background through your eyes. I like this now. Okay. Now I look like I'm here to study and not. I don't know what the other one looked like. It just felt fun. But this one looks more serious. Yeah. So I just wanted to say that just the fact that there are, one or maybe more people that is, here is more important than me being derailed. Like the fact that you're here to talk to me is something to be thankful for. Okay, so please don't think that. Yeah, I'm not happy that someone is talking to me. That's all I wanted to say, and then we can go and start some learning. Oh, hi, 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 hi. How did it go? How did you do? I'm better today, by the way. I was I was not well, very well yesterday. Yes. By the way, I need to clear my throat. I don't know what's happening. Thank you. Thank you. Thank you. I think better for now, for the time being. I was thinking collab is here. I was thinking that go. Alhamdulillah. I was thinking instead of Tiny Shakespeare, we can test it on something else, like something with a different language. How would that be? Because we're doing it on character level. Wouldn't that be fun? So like we are just going with whatever he's saying. But if there's anything English related, then we can do something about it. I think that would be pretty fun. So is there anything anywhere that I can use? I don't have anything on my mind right now, like a maybe large chunk of text that's pretty clean and is not in English. Has to be out there somewhere. My brain is frozen a bit. Do I just give it like copy somewhere and paste it instead of put it in this text? I feel like I should do that. Like go to some Wikipedia. Yeah. You could look for K-drama subtitles, then we won't be able to tell if it worked or not. Ha. Good. Okay. I'm gonna try to look for some GitHub repo with GitHub K-drama sub. Let me see if anything like this exists. Korean drama deep learning. Wow. MashaAllah. Can you see this? I am going to. You can't, obviously, but like I'm just saying, can you see this? What is that? I was thinking Hungary might work well for character model. Good point. What is that? Generate human-like chatbot, my Korean drama. Save. No, that's fine. Okay, let me go to. I doubt I would subtitles. Doubt I would find anything. Huh? Ooh. Whoa, this is not what I wanted. Oh yeah. Wait, is that a okay, that's repository for vet. Oh, that's not that's is that the YouTube channel? Huh? I think HuggingFace may have open subs. Oh, okay, we can try that. HuggingFace open subs. But there was this one I was like, what is that? Subtitle data. Silicon Valley subtitles. Bloom? As in dream? Gaming? Any town isn't oh, anime. No. Anime with Korean subtitles. Oh, this one looks like what I want. Basic. Sub. Ah, oh, it looks like a table. I mean, I can probably put it together, but let's check Hugging Face just in case. Do I just look for subs? I don't know why I'm too lazy to write the. Oh, what was that? Oh, there's a. Nope. Subtitle. Korean? Anyone? Oh, no results found. Yeah, sure. Search. Where am I searching? Huh? Egyptian? Oh, open subtitles. Okay, that's something. How many languages do we have? Sorry. Korean. Whoa. Okay. View, please. Oh. Whoa. What's wrong? Huh? There's an error. That's fun. How does it look? Input language, target language, input text, output text. This is fun. I want to see it. Ah, wait. Why have I seen this? Is that a company? Hmm? Hmm. Okay. So let me try and call it. Well, what's wrong? Can I not use it? Oh, hi. Hi, Doppler. What's up? Okay. I still. I want to see what this says. Ah. Ooh. Wow. Nice. That's too complicated for me. We have two different subtitles. And then let's see how we can use it. Might be big to clone entire thing. I mean, what about if I just clone the load the. First of all, I need to copy this to my drive. All right. I'm gonna just read the Korean side and let's see. Is it ko or oh wait? I don't care. But you know what? It's fine. English and Korean, if it exists, is Korean ko or KOR? Languages. There we go. It is ko. Okay. So I guess, let's see. I have to, sorry. Korean subs. That's a test. I need to, do I need to pip install? I bet I need to pip install, install, data set. And then I probably need to import it. It's called dataset, right? Oh shoot, I didn't mean to run you. No. Anyway. Okay, you do that. Today I forgot to bring something to. Huh? What? Oh, the air is here, not there. You didn't get an air. Got it. I forgot to bring something to have with the coffee. Sometimes I bring a piece of cookie or some. I wouldn't call it candy, but it's technically candy. Motorcycle passing. And I just like look around and I see there's one that I forgot to eat yesterday. I like those sort of surprises. So we say from data set import load data set. There. Eh? What is my, where did I mess up? I did it wrong. Help me. How does one load a data set? Oh, rerun. That's a good point actually. Rerun. I'm gonna, yeah, data sets with an S. That was my mistake. Data sets has an S. Let's check which one is the bigger error, whether I need to restart the session or dataset was missing an S. Pip the HuggingFace stuff. Hey, another error. Let's see. Could be. Sure. Trust remote code. Good point. Logging into HuggingFace. I didn't see it as a requirement. Shouldn't they say if it's a requirement? It's loading. I should have also added this part. Trust remote code. Something's loaded. And then I'm supposed to clean it up before I make it a full text thing. No, but it did say viewer is disabled because this repo requires arbitrary Python code execution. Don't know what that means. If it breaks, we'll fix it. Yes, yes, I am running it here. So we'll let this run and we'll go to our friend Andre Karpathy. I should probably refresh this because this is from yesterday. I did not touch it technically.
Okay, so now that we have our...
Okay. I think we'll do tokenizer next. No, we'll do language model, simple language model.
Our batch of input that we'd like to feed into a transformer, let's start basically feeding this into neural networks. Now, we're going to start off with the simplest possible neural network, which in the case of language modeling, in my opinion, is the bigram language model. And we've covered the bigram language model in my Make More series in a lot of depth. And so here I'm going to sort of go fast.
Question to the chat. Did anyone try to watch any of this yesterday? Because I had 2 people thinking they might. I was like, should I not? I was like, I'm not gonna betray those people who trust me to watch it on stream. I'm kidding, I was too lazy to watch it.
Faster, and let's just implement the PyTorch module directly that implements the bigram language model. So I'm importing the PyTorch NN module for reproducibility. And then here I'm constructing a bigram language model, which is a subclass of NN module. And then I'm calling it, and I'm passing in the inputs and the targets.
No way.
And I'm just
You watched the Make More? I think that was it. Cool. You watched it yesterday, or you'd already seen them? Guessing you might have already seen some of them, because they're mostly like our videos, right? I think.
printing. Now, when the inputs and targets come here, you see that I'm just taking the index, the inputs x here, which I renamed to IDX, and I'm just passing them into this token embedding table. So what's going on here is that here in the constructor, we are creating a token embedding table, and it is of size vocab size by vocab size. And we're using NN.embedding, which is a very thin wrapper around basically a tensor of shape vocab size by vocab size. And what's happening here is that when we pass IDX here, every single integer in our input is going to refer to this embedding table and is going to pluck out a row of that embedding table corresponding to its index. So 24 here will go to the embedding table and will pluck out the 24th row. And then 43 will go here and pluck out the 43rd row, etc. And then PyTorch is going to arrange all of this into a batch by time by channel tensor. In this case, batch is 4, time is 8, and C, which is the channels, is vocab size, or 65. And so we're just going to pluck out all those rows, arrange them in a B by T by C, and now we're going to interpret this as the logits, which are basically the scores for the next character in a sequence. And so what's happening here is we are
I was going to start trying to code a simple model. Oh. Okay. You went down the rabbit hole. Yeah. It's happened to me. I was like, last time I was trying to work on something, I wrote down a bunch of, like, I tried to do the research beforehand so that when it comes to implementation, I don't do more research. And then when it came to implementation, I was also looking around and somewhat wasting my time, you know? Yeah. Oh, it ran. We're done? Do I look at data set? I'm guessing we had train. Should I not guess and look at data sets first? Data set. Let's see what we have in there. We do have train. Meta and translation. Oh, wait, is that 1 million rows? Only for Korean? Whoa. Through the snow and sleet and hail. Oh, that's so, beautiful. Oh, there's an IMDb ID. Oh, I'm curious. 1941? You're kidding. What is this? Anyway, we only need the translation. It's so pretty. Whoa. Well, I can do remove columns. And what can I do after that? How do I concatenate it? And where does remove columns come from? Do I just say database dot remove columns? I'm not sure. I'm gonna try though. The idea is to remove everything. And I'm not supposed to do it on the dataset. I'm supposed to do it on a sample. You know what? I can. Nice. Let's make a sample. So much stuff. Assume a Gaussian. There we go. Distribution, but language follows something more like a Zipf's law. I know that one. But I don't know about power or Pareto. No. This is not yeah. Is Gaussian distribution supposed to be the bell curve? Language is the one with the long tail. No. It's another thing. It's a normal distribution. Wait. Oh, it is the bell curve. Why did it look like this here? Yeah. Yep. And then we have yeah, sure, for language, this long tail thing. Yep. Yeah, basically the and all of that is like at the top, and then other words are at the other side. I'm thinking we take, does that mean top 10? No, not how it works. Slice. Oh, I forgot to say train. Sorry. I mean, you only have train. Don't. Swear to God. Here. Remove the train. Happy? Now I'm happy. Good. I can say dot remove columns, and then we had ID, we had meta, we had, what else did we have? Oh, data field is empty. Wait. English and so many different Arabics. Okay. Oh wow, these are different corpora. Whoa. Well, you're not telling me how it is. Okay, I'm gonna find it myself. That's cool. Model cards, yeah. Yes, that's why they made a tutorial. Yeah. We saw the paper, right, about the model card. So that exists. Sample. What do you have? You have all of this. Nice. ID, meta, IMDb ID, subtitle ID. Whoa. This is a bit complicated, huh? Translation. What is happening? Why are they separated? Are you seeing what I'm seeing? Translation is in a different part. Okay, let's see if I remove this, what happens. That's not how it works. How does it work? I don't think I'm calling it here. Oh, okay, wait. Am I calling it here? Remove columns, remove columns. I am not. Remove. Oh, am I? No, and no. Take me back to when we were making a model. Or a data set, yeah. Remove. Hey, fine. Take me to docs. I forgot everything that I ever learned. Because I want to remove column. N. There should be an N. We call. There. Find it for me. It is though. Oh, did I forget the S again? No. I'm doing this because. What's the problem? It's not. Oh, it's a dictionary object. It's not a. My bad. Well, I messed it up. I messed it up. Okay, I need to fix this. We're removing them because the one that Andre is using, I should not do this one because it makes it a dictionary object. I should just do a train. Train. Would that be okay? Still looks the same though. Still. So I should probably do the remove columns. I don't get it. Okay, maybe I do. I don't. So his data set is a long list of text that's called Tiny Shakespeare, and I'm trying to recreate that. We can look at it. See, this is it. This is the data set. All right. I'm not giving up quite yet. Can't seem to keep the data set. I mean, if I do it for the whole thing, it would be costly. That's why I don't want to do it for the whole thing. Or I can just make my data sets smaller. Because I have to do that one. What else do I want to do before that though? Remove the stuff and then put them together. I think I'm gonna just try. Wait, can I make a function that? No, I can't do this then. I have to remove it first. Am I overcomplicating this for myself? It does seem that way. We are killing the sample for now. I just need you people. Okay. I'm not gonna do anything. Can I map and just remove columns? Is that possible? How big is Tiny Shakespeare? Very small. We can find another file to use. Like old sci-fi stories or something. Ah. Good point. Good point. I'm gonna try running this while we think about Not in the data set. You're kidding. Do I say? Can't be serious. Oh, they're actually no longer there? They were removed? How did that happen? I don't get it. What did I do? Old book. Oh, Sherlock Holmes is no longer copyrighted. LibriVox it's mostly text, but let's see. Sherlock Holmes book text. And then stories in plain text format. Woo. And it's from Sherlock Holmes. Yes. Wow, nice. Ooh, complete canon. Before. Oh, that's so pretty. Oh, I'm gonna cry now. Oh, that's too much. Is it too much? I'm gonna say languages. Or like, oh, actually translation might be better. I doubt it would exist, but I'm still gonna try. Yeah. Yeah. Sherlock is the first thing in my brain. Always. My first true love. We can even keep those. I don't care. But is it? Did it say? Oh yeah, it does say. Yeah, that's pretty okay, I suppose. This one's the biggest. Return. I'm sad to say I have not completed the whole canon. I think I was like somewhere around Valley of Fear, maybe? Anyway, so let's take this just right. We can worry about this one next time. I'm not gonna remove it. I'm gonna have a title that says Sherlock. And then, I should probably put that link here. There. And then we can use it. With wget, I wanted to put this as a title so that I can close it. And then, well, oh, there it is. Okay. And then we do wget. And then it's called Cano. It's not called text. So, oh, our own little tiny Sherlock. Would he be mad about it? Cano. It is 3 million. All right. We got it. Unique characters. Whoa. What are these here for? Maybe names, right? Names of, let's say, like, characters. Encode entire data set. That might take time, actually. And then splitting. Block size, something we discussed. The thing with the flow thing. When you have a language model trained on it, maybe you can estimate if you would be mad about it. Like Sherlock found out he was in a simulation. So I think that's in all the canons where Sherlock does not know the Earth revolves, well, moon around Earth, Earth around sun, all of that. He does not know that because he doesn't need to know, because it is taking up space, so he doesn't need to know that. I'm sure he would be like, I don't need to know that I'm in a simulation. It does not change anything. I need to solve crimes. That is my canon. That is also about splits. Sure. We were right here. We paused right here. Okay, we're not gonna make it multilingual. I have done this. Like sometimes I try to test it with a different language and then I fail and then I go back and test the original version and then find an error. That happened to me a few days ago. Like I couldn't even run it English version. Probably my fault, but still. So output is logits that goes to the next what?
For the next character in a sequence.
Character.
And so what's happening here is we are predicting what comes next based on just the individual identity of a single token. And you can do that because, currently the tokens are not talking to each other and they're not seeing any context except for they're just seeing themselves. So I'm a token number 5, and then I can actually make pretty decent predictions about what comes next just by knowing that I'm token 5, because some characters follow other characters in typical scenarios. So we saw a lot of this in a lot more depth in the Make More series. And here, if I just run this, then we currently get the predictions, the scores, the logits for every one of the 4x8 positions. Now that we've made predictions about...
We can do that? Like we can have a relationship. This is bigram level.
What comes next, we'd like to evaluate the loss function. And so in Make More series, we saw that...
Sounds like a philosophy to deal with chat derailing. Do I need to know this to learn? Yeah. Oh, okay. That's interesting. It depends on how talkative the person is. If the person wants to be distracted, then yeah. Yeah, let's talk about this more.
A good way to measure a loss, or like a quality of the predictions, is to use the negative log likelihood loss, which is also implemented in PyTorch under the name cross entropy. So what we'd like to do here is loss is the cross entropy on the predictions and the targets. And so this measures the quality of the logits with respect to the targets.
Mm-hmm.
In other words, we have the identity of the next character. So how well are we predicting the next character based on the logits? And intuitively, the correct dimension of logits, depending on whatever the target is, should have a very high number, and all the other dimensions should be very low number, right? Now, the issue is that this won't actually...
Can you tell me that again?
And intuitively, the correct dimension of logits, depending on whatever the target is, should have a very high number, and all the other dimensions should be very low number, right? Now, the issue is that this won't actually... This is what we want. We want to basically output the logits and the loss.
Mm-hmm.
This is what we want, but unfortunately, this won't actually run. We get an error message. But intuitively, we want to measure this. Now, when we go to the PyTorch cross-entropy documentation here, we're trying to call the cross-entropy in its functional form. So that means we don't have to create like a module for it. But here, when we go to the documentation, you have to look into the details of how PyTorch expects these inputs. And basically, the issue here is PyTorch expects, if you have multi-dimensional input, which we do because we have a b by t by c tensor, then it actually really wants the channels to be the second dimension here. So if you, so basically, it wants a b by c by t instead of a b by t by c.
Right.
And so it's just the details of how PyTorch treats these kinds of inputs. And so we don't actually want to deal with that. So what we're going to do instead is we need to basically reshape our logits. So here's what I like to do. I like to basically give names to the dimensions. So logits.shape is b by t by c, and unpack those numbers. And then let's say that logits equals logits.view, and we want it to be a b times t by c. So just a two-dimensional array.
Why?
right? So we're going to take all of these positions here, and we're going to stretch them out in a one-dimensional sequence and preserve the channel dimension as the second dimension. So we're just kind of like stretching out the array so it's two-dimensional, and in that case, it's going to better conform to what PyTorch sort of expects. And
I was worried that this by would make it us lose the numbers.
its dimensions. Now we have to do the same to targets, because currently targets are of shape b by t, and we want it to be just b times t, so one-dimensional. Now, alternatively, you could always still just do -1, because PyTorch will guess what this should be if you want to lay it out, but let me just be explicit and say b times t. Once we've reshaped this, it will match the cross-entropy case, and then we should be able to evaluate our loss. Okay, so that ran now, and we can do loss. And so currently we see that the loss is 4.87. Now, because we have 65 possible vocabulary elements, we can actually guess at what the loss should be. And in particular, we covered negative log likelihood in a lot of detail. We are expecting log, or ln, of 1/65 and negative of that. So we're expecting the loss to be about 4.17, but we're getting 4.87. And so that's telling us that the initial predictions are not super diffuse. They've got a little bit of entropy. And so we're guessing wrong. Yes. But actually, we are able to evaluate the loss. Okay, so now that we can evaluate the quality of the model on some data, we'd like to also be able to generate from the model. So let's do the generation. Now I'm going to go again a little bit faster here because I covered all of this already.
I forgot we were supposed to be generating something
In the previous videos. So
he's really making me go back and watch his make more stuff. But again, I stand by my philosophy of starting somewhere uncomfortable and then going back and learning more.
Here's a generate function for the model. So we take the same kind of input, IDX here. And basically, this is the current context of some characters in some batch. So it's also b by t, and the job of generate is to basically take this b by t and extend it to be b by t plus 1, plus 2, plus 3, and so it's just basically, it continues the generation in all the batch dimensions in the time dimension. So that's its job, and it will do that for max new tokens. So you can see here on the bottom, there's going to be some stuff here, but on the bottom, whatever is predicted is concatenated on top of the previous IDX along the first dimension, which is the time dimension, to create a b by t plus 1. So that becomes the new IDX. So the job of generate is to take a b by t and make it a b by t plus 1, plus 2, plus 3, as many as we want max new tokens. So this is the generation from the model. Now, inside the generation, what are we doing? We're taking the current indices, we're getting the predictions. So we get, those are in the logits. And then the loss here is going to be ignored because we're not using that, and we have no targets that are sort of ground truth targets that we're going to be comparing with. Then once we get the logits, we are only focusing on the last step. So instead of a b by t by c, we're going to pluck out the -1, the last element in the time dimension, because those are the predictions for what.
That was something, one of the to-dos. Last, where was I? Classifier? Classifier, ABC, there it is. Something about the where was it? Final token. No, that. Oh well, I thought it was the same thing. Guess it's not.
Comes next. So that gives us the logits, which we then convert to probabilities via softmax. And then we use torch.multinomial to sample from those probabilities. And we ask PyTorch to give us one sample. And so IDX next will become a b by 1, because in each one of the batch dimensions, we're going to have a single prediction for what comes next. So this num samples equals 1 will make this be a 1. And then we're going to take those integers that come from the sampling process, according to the probability distribution given here, and those integers just get concatenated on top of the current sort of like running stream of integers. And this gives us a p by t plus 1. And then we can return that. Now, one thing here is, you see how I'm calling self of idx, which will end up going to the forward function. I'm not providing any targets. So currently this would give an error because targets is sort of like not given.
Right.
So targets has to be optional. So targets is none by default. And then if targets is none, then there's no loss to create. So it's just loss is none.
We only return
Else,
logits.
all of this happens and we can create a loss. So this will make it so if we have the targets, we provide them and get a loss. If we have no targets, we'll just get the logits. So this here will generate from the model. And let's take that for a ride now. Oops. So I have another code chunk here, which will generate for the model, from the model. And okay, this is kind of crazy. So maybe let me let me break this down. So these are the IDX, right?
Oh, thank you. I was like, how is he going to break it down?
I'm creating a batch will be just 1. Time will be just 1.
Oh.
So I'm creating a little 1-by-1 tensor, and it's holding a 0. And the D type, the data type is integer.
Okay.
So 0 is going to be how we kick off the generation. And remember that 0 is the element standing for a new line character. So it's kind of like a reasonable thing to feed in as the very first.
We have the first element. What is my first element? Space, maybe?
Character in a sequence to be the new line. So it's going to be IDX, which we're going to feed in here. Then we're going to ask for 100 tokens. And then n.generate will continue that. Now, because generate works on the level of batches.
I can't compute that this code returns, generation. Is there more? Is that it? Like, I'm sorry, I really don't understand what's happening. I know he said go back to the other videos where he explains more. And like, logically, I get it. We have the thing for each of them in context of batches. But yeah.
We then have to index into the 0th row to basically unblock the single batch dimension that exists. And then that gives us a time steps, just a one-dimensional array of all the indices, which we will convert to simple Python.
How are we choosing the next thing? Did I forget or did we talk about it? Because like, it was for the next character. Do we calculate the next character? Is that the idea?
Python list from PyTorch tensor, so that can feed into our decode function and convert those integers into text. Okay. So let me bring this back, and we're generating 100 tokens. Let's run. And here's the generation that we achieved.
Yes, but even this has to do generation. See, it did something. It's horrible, but it did something.
So obviously it's garbage, and the reason it's garbage is because this is a totally random model. So next up, we're going to want to train this model. Now, one more thing I wanted to point out here is this function is written to be general, but it's kind of like ridiculous right now because we're feeding in all this, we're building out this context, and we're concatenating it all, and we're always feeding it all into the model. But that's kind of ridiculous because this is just a simple bigram model. So to make, for example, this prediction about k, we only needed this w. But actually what we fed into the model is we fed the entire sequence. And then we only looked at the very last piece and predicted k. So the only reason I'm writing it in this way is because right now this is a bigram model. But I'd like to keep this function fixed, and I'd like it to work later when our characters actually basically look further
Context.
in the history. And so right now the history is not used, so this looks silly, but eventually the history will be used. And so that's why we want to do it this way.
Okay.
So just a quick comment on that. So now...
Wait, what? Is there something wrong with the stream? Because OBS is telling me something about something overloading. The reason I looked at it, it said encoder or maybe decoder, I don't know. Overloading video something something. Because we are talking about encoders and decoders, that's why it grabbed my attention. So if I run this and then do the... Oh god. Is there anything that's illegible? We have new lines. That's pretty cool. Okay. Okay. Thank you. Thank you. It's okay. Maybe it was just a warning. Because now, like, everything is good. Remember those days when the streaming was done on a potato?
We see that this is...
Huh. Ah, really? I don't know. Monitoring seems fine. Okay. Thank you. Yeah. All right. Where were we?
Random this way. So just a quick comment on that. So now we see that this is random. So let's train the model so it becomes a bit less random. Okay, let's now train the model. So first what I'm going to do is I'm going to create a PyTorch optimization object. So here we are using the optimizer
Adam
W. Now in the Make More series, we've only ever used stochastic gradient descent, the simplest possible optimizer, which you can get using the SGD instead. But I want to use Adam, which is a much more advanced and popular optimizer, and it works extremely well. For typical good setting for the learning rate is roughly 3e-4. But for very, very small networks, like is the case here, you can get away with much, much higher learning rates, 1e-3 or even higher probably. But let me create the optimizer object, which will basically take the gradients and update the parameters using the gradients.
Okay.
And then here, our batch size up above was only 4. So let me actually use something bigger, let's say 32. And then for some number of steps, we are sampling a new batch of data. We're evaluating the loss. We're zeroing out all the gradients from the previous step, getting the gradients for all the parameters, and then using those gradients to update our parameters. So typical training loop as we saw in the Make More series. So let me now run this for say 100 iterations and let's see what kind of losses we're gonna get. So we started around 4.7.
Ooh, going down.
And now we're getting down to like 4.6, 4.5, etc. So the optimization is definitely happening, but
not great.
Let's sort of try to increase the number of iterations and only print at the end, because we probably want to train for longer.
Oh, nice.
Okay, so we're down to 3.6 roughly. Roughly down to 3.
Oh. How far do we want to go?
This is the most janky optimization.
It's funny.
Okay, it's working. Let's just...
There's no dead air. Yeah. Yes, I agree. It's very packed.
do 10,000.
All right.
And then from here, we want to copy this. And hopefully, we're going to get something reasonable.
Oh, no way. Like, so just optimizing? I will make mine 10,000. Should I make it higher? Like maybe like 25,000? Because he ran it way too many times. I want my tiny Sherlock to be perfect, as he always is.
Reasonable. And of course, it's not going to be Shakespeare from a bigram model, but at least we see that the loss is improving. And hopefully we're expecting something a bit more reasonable. Okay, so we're down at about 2.5-ish. Let's see what we get. Okay.
Ooh.
Well, dramatic improvement certainly on what we had here. So let me just increase the number of tokens. Okay, so we see that we're starting to get something at least like reasonable-ish.
Like there are apostrophes. Shakespeare uses apostrophes, no?
Certainly not Shakespeare, but the model is making progress. So that is the simplest possible model.
Beautiful.
So now what I'd like to do is, obviously this is a very simple model because the tokens are not talking to each other. So given the previous context of whatever was generated, we're only looking at the very last character to make the predictions about what comes next.
Is 25 too much? Oh, we did it. 2.3. Hey, hey. And let's print something. There's an I. Us. Ooh, this looks like a name. Cool. It is better though. That's cool. Okay. Yeah, pretty good. Proud of our tiny boy.
So now these tokens have to start talking to each other and figuring out what is in the context so that they can make better predictions for what comes next. And this is how we're going to kick off the transformer. Okay, so next, I took the code that we developed in this Jupyter notebook and I converted it to be a script. And I'm doing this because I just want to simplify our intermediate work into just the final product that we have at this point. So in the top here, I put all the hyperparameters that we've defined. I introduced a few, and I'm going to speak to that in a little bit. Otherwise, a lot of this should be recognizable. Reproducibility, read data, get the encoder and the decoder, create the train and test splits, use the kind of like data loader that gets a batch of the inputs and targets. This is new, and I'll talk about it in a second. Now, this is the bigram language model that we developed, and it can forward and give us a logits and loss, and it can generate. And then here we are creating the optimizer, and this is the training loop. So everything here should look pretty familiar. Now, some of the small things that I added. Number one, I added the ability to run on a GPU if you have it. So if you have a GPU, then this will use CUDA instead of just CPU, and everything will be a lot more faster. Now, when device becomes CUDA, then we need to make sure that when
The reason I'm quiet is that there's background noise. I'll stay quiet for a bit.
we load the data, we move it to device. When we create the model, we want to move the model parameters to device. So as an example, here we have the NN embedding table, and it's got a .weight inside it, which stores the sort of lookup table. So that would be moved to the GPU so that all the calculations here happen on the GPU and they can be a lot faster. And then finally here, when I'm creating the context that feeds into generate, I have to make sure that I create it on the device. Number two, what I introduced is the fact that here in the training loop, here I was just printing the loss.item inside the training loop. But this is a very noisy measurement of the current loss because every batch will be more or less lucky. And so what I want to do usually is I have an estimate loss function, and the estimate loss basically then goes up here, and it averages up the loss over multiple batches. So in particular, we're going to iterate eval iter times, and we're going to basically get our loss, and then we're going to get the average loss for both splits. And so this will be a lot less noisy. So here, when we call the estimate loss, we're going to report the...
Yeah, I'm going to repeat that.
And so what I want to do usually is I have an estimate loss function, and the estimate loss basically then goes up here, and it averages up the loss over multiple batches. So in particular, we're going to iterate eval iter times, and we're going to basically get our loss, and then we're going to get the average loss for both splits. And so this will be a lot less noisy. So here, when we call the estimate loss, we're going to report the pretty accurate train and validation loss. Now, when we come back up, you'll notice a few things here. I'm setting the model to evaluation phase, and down here I'm resetting it back to training phase. Now, right now for our model as is, this doesn't actually do anything, because the only thing inside this model is this nn.embedding, and this network would behave the same in both evaluation mode and training mode. We have no dropout layers, we have no batch norm layers, etc. But it is a good practice to think through what mode your neural network is in, because some layers will have different behavior at inference time or training time. And there's also this context manager, torch.nograd, and this is just telling PyTorch that everything that happens inside this function, we will not call .backward on. And so PyTorch can be a lot more efficient with its memory use because it doesn't have to store all the intermediate variables because we're never going to call backward. And so it can be a lot more memory efficient in that way. So also a good practice to tell PyTorch when we don't intend to do backpropagation. So right now, this script is about 120 lines of code, and that's kind of our starter code. I'm calling it bigram.py, and I'm going to release it later. Now, running this script gives us output in the terminal, and it looks something like this. It basically, as I ran this code, it was giving me the train loss and the val loss, and we see that we convert to somewhere around 2.5 with the bigram model. And then here's the sample that we produced at the end. And so we have everything packaged up in the script, and we're in a good position now to iterate on this. Okay, so we are almost ready to start writing our very first self-attention block.
Background noise is still there.
For processing these tokens. Now, before we actually get there, I want to get you used to a mathematical trick that is used in the self-attention inside a transformer, and is really just like at the heart of an efficient implementation of self-attention. And so I want to work with this toy example to just get you used to this operation, and then it's going to make it much more clear once we actually get to it in the script again. So let's create a b by t by c, where b, t, and c are just 4, 8, and 2 in this toy example. And these are basically channels, and we have batches, and we have the time component, and we have some information at each point in the sequence, so c. Now, what we would like...
I'm gonna try eliminate the background noise. Give me like 2 seconds. I don't think I succeeded, but I hope that noise cancellation can... Can you hear something in the background when I'm talking?
like to do is we would like these tokens. So we have up to 8 tokens here in a batch. And these 8 tokens are currently not talking to each other, and we would like them to talk to each other. We'd like to couple them. And in particular, we want to couple...
It's less people talking and more whoosh, 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 something like that. Like close to AC. I also have AC on, so I hope they're like being mixed together and gone together.
couple them in a very specific way. So the token, for example, at the 5th location, it should not communicate with tokens in the 6th, 7th, and 8th location,
But
because those are future tokens in the sequence.
backward, but not forward. Okay.
The token on the 5th location should only talk to the one in the 4th, 3rd, 2nd, and 1st. So information only flows from previous context to the current time step. And we cannot get any information from the future because we are about to try to predict the future. So what is the easiest way for tokens to communicate? Okay, the easiest way I would say is, okay, if we're a 5th token and I'd like to communicate with my past, the simplest way we can do that is to just do an average of all the preceding elements. So for example, if I'm the 5th token, I would like to take the channels that make up that are information at my step, but then also the channels from the 4th step, 3rd step, 2nd step, and the 1st step.
Okay.
I'd like to average those up And then that would become sort of like a feature vector that summarizes.
By average, are you saying we average out the numbers?
Me in the context of my history. Now, of course, just doing a sum or like an average is an extremely weak form of interaction. Like this communication is extremely lossy. We've lost a ton of information about the spatial arrangements of all those tokens. But that's okay for now. We'll see how we can bring that information back later. For now, what we would like to do is...
Yeah, that's what I was thinking. Like, wouldn't we lose information?
For every single batch element independently, for every teeth token in that sequence, we'd like to now calculate the...
Sorry. That seems like a bad idea, Andre. Oh. Ah. Are we synced? I'm laughing at the caption. He meant 10th, right? Every teeth token. We should have some teeth token.
The average of all the vectors in all the previous tokens and also at this token. So let's write that out. I have a small snippet here, and instead of just fumbling around, let me just copy paste it and talk to it. So in other words, we're going to create X, and BOW is short for bag of words, because bag of words is kind of like a term that people use when you are just averaging up things. So this is just a bag of words. Basically, there's a word stored on every one of these 8 locations, and we're doing a bag of words, so just averaging.
Is bag of words average of representations of words? I thought it was unordered list. Oh well.
So in the beginning, we're going to say that
it turned migrant token to migrant. Ah, yeah. I love the Yep. Pretty great though.
That it's just initialized at 0, and then I'm doing a for loop here, so we're not being efficient.
I'm sure people have but I'm gonna show. Oh well. I'm sure people know how it can be done, but I'll show it just in case someone might not know that you can auto-translate. Isn't that like the coolest thing? It doesn't have like every language, but it has, I'd say 90% of languages. Like if we try for Arabic and I go back like, look at this.
Locations, and we're doing a bag of words, so just averaging. So in the beginning, we're going to say that it's just initialized at 0.
لذلك في بداية سنبدأ لنقول, look at this. How cool is this? Anyway.
0. And then I'm doing a for loop here, so we're not being efficient yet. That's coming. But for now, we're just iterating over all the batch dimensions independently, iterating over time, and then the previous tokens are at this batch dimension, and then everything up to and including the teeth token. Okay? So when we slice out X in the
teeth token, okay, I now side with YouTube because teeth. That makes every sense.
This way, xprev becomes of shape, how many t elements there were in the past, and then of course c, so all the two-dimensional information from these little tokens. So that's the previous sort of chunk of tokens from my current sequence. And then I'm just doing the average or the mean over the 0th dimension. So I'm averaging out the time here. And I'm just going to get a little c one-dimensional vector, which I'm going to store in x bag of words. So I can run this, and this is not going to be very informative because, let's see, so this is x of 0, so this is the 0th batch element, and then expo at 0. Now, you see how at the first location here, you see that the two are equal. And that's because we're just doing an average of this one token. But here, this one is now an average of these two.
Is this called a running average? Or is that...
And now this one is an average of these 3.
Okay.
And so on.
Now there's less information being lost, right? Translation must make understanding like teeth token so much worse. Oh yeah, now I'm curious. Teeth. Asnan. And token, I don't know what that's called in Arabic. I'm assuming it's, I don't know. I shouldn't assume, but I'm assuming it's just the word token made to sound Arabic.
So, and this last one is the average of all of these elements. So vertical average, just averaging up all the tokens, now gives this outcome here. So this is all well and good, but this is very inefficient. Now the trick is that we can be very, very efficient about doing this using matrix multiplication.
Little note, I was watching CS50 with someone, and we had subtitle of another language on, and there was a, like, I noticed an error in the subtitle, even though I can't speak the language. And I was like, wait, that's not what he meant. And then I explained the joke. I think it was a joke, as far as I remember. And yeah, the subtitle made it so much worse. But like, most of the time, it's just a tiny little thing. Yeah.
Multiplication. So that's the mathematical trick. And let me show you what I mean. Let's work with the toy example here. Let me run it and I'll explain. I have a simple matrix here that is a 3 by 3 of all ones, a matrix B of just random numbers, and it's a 3 by 2, and a matrix C, which will be 3 by 3 multiplied 3 by 2, which will give out a 3 by 2. So here we're just using matrix multiplication. So A multiply B gives us C. Okay, so how are these numbers in C achieved, right? So this number in the top left is the first row of A dot product with the first column of B. And since all the row of A right now is all just ones, then the dot product here with this column of B is just going to do a sum of this column. So 2 plus 6 plus 6 is 14. The element here in the output of C is also the first column here, the first row of A, multiplied now with the second column of B. So 7 plus 4 plus 5 is 16. Now you see that there's repeating elements here. So this 14 again is because this row is again all ones, and it's multiplying the first column of B. So we get 14. And this one is, and so on. So this last number here is the last row, dot product, last column. Now the trick here is the following. This is just a boring number of, is just a boring array of all ones, but Torch has this function called trill, which is short for a try.
Ramuz. Language model token. Okay. Ramuz means symbol or, yeah, that is a good one. Yeah, I'm sure Arabic has words for everything. I should never doubt it. Half of English is, or actually half of Spanish is basically Arabic. I don't know. Just a lot of scientific words come from Arabic. Like if, I'm probably have talked about this, so I shouldn't, but a lot of astronomy. A lot of astronomy is Arabic names, which is pretty cool. Also math. Yeah, anyway, also chemistry. Okay, I should stop. You get it.
Triangular, something like that. And you can wrap it in torch.once, and it will just return the lower triangular portion of this. Okay. So now it will basically zero out these guys here. So we just get the lower triangular part. Well, what happens if we do that? So now we'll have A like this and B like this. And now what are we getting here in C? Well, what is this number? Well, this is the
same as here.
First row times the first column. And because this is zeros, these elements here are now ignored. So we just get a 2. And then this number here is the first row times the second column. And because these are zeros, they get ignored, and it's just 7. This 7 multiplies this 1.
Oh yeah, Arabic digits. I forgot that. Yeah. Especially with the zeros. Those people had zeros. What?
But look what happened here. Because this is 1 and then zeros,
and look, we're using them here.
We're just plucking out the row of this row of B, and that's what we got. Now here we have 110. So here, 110 dot product with these two columns will now give us 2 plus 6, which is 8, and 7 plus 4, which is 11. And because this is 111, we ended up with the addition of all of them. And so basically, depending on how many ones and zeros we have here, we are basically doing a sum currently of a variable number of these rows, and that gets deposited into C. So currently we're doing sums because these are ones, but we can also do average, right? And you can start to see how we could do average of the rows of B sort of in an incremental fashion. Because we don't have to, we can basically normalize these rows so that they sum to 1, and then we're going to get an average. So if we took A, and then we did A equals A divide, torch.sum in the, of A, in the 1th dimension, and then let's keep them as true. So therefore the broadcasting will work out. So if I rerun this, you see now that these rows now sum to 1. So this row is 1, this row is 0.5, 0.5 is 0, and here we get 1/3. And now when we do A multiply B, what are we getting? Here we are just getting the first row, first row. Here now we are getting the average of the first two rows.
He's so evil in a good way. Like, he's a genius there, without the evil.
Okay, so 2 and 6 average is 4, and 4 and 7 average is 5.5. And on the bottom here, we are now getting the average of these 3 rows. So the average of all of elements of B are now deposited here. And so you can see that by manipulating these elements of this multiplying matrix, and then multiplying it with any given matrix, we can do these averages in this incremental fashion, because we just get, and we can manipulate that based on the elements of A.
There's a book on what a big idea 0 was to mathematics. I can't be sure if it was Veritasium or if it was Vsauce, but I'm sure I've watched a video about the significance of 0. Yeah. Do I remember it? No. Yeah. Okay. But yeah. Yeah. There was a time before the internet and there was a time before 0.
Okay, so that's very convenient. So let's swing back up here and see how we can vectorize this and make it much more efficient using what we've learned. So in particular,
we wouldn't have a language model if 0 didn't exist.
We are going to produce an array A, but here I'm going to call it way, short for weights.
Okay.
But this is our A. And this is how much of every row we want to average up. And it's going to be an average because you can see that these rows sum to 1. So this is our A. And then our B in this example, of course, is...
Biography of a Dangerous Idea. Cool. I don't know why I have less time to listen to audiobooks, but I like listening to nonfiction. Cool. Hindus. Whoa. Huh? What? What? Demonic? Cool, cool. Four stars? Whoa, that's a... Okay. I am not distracted. Where are we? Matrix multiply. Ooh, softmax! Hey. minor cleanup. And then I'm guessing this is a test. And then we get version 4 self-attention. Okay. Okay.
X.
Oh, it was in
So what's going to happen here?
it was in Persian. Like, even if I tried to read it, I would like, I was like, should I embarrass myself and try to read it? Because I can't speak Persian. But it says, is that supposed to be the author's name? What was the author's name? Charlie? No, it's not the author's name. As Seri, I don't know what that is supposed to mean. This is number 1, number 2, that I can tell. The Dalili means proof. أعداد همیشه فصل از داستان زندگی من بودن. I don't know what أعداد is supposed to mean here. Numerically, I don't know. همیشه means always. يا فصل this portion. As means me. داستان means story, I suppose. It can mean other stuff. زندگی means life. من بودن. Oh, my life story. Whose life story? اما این فصل در کلاس دوم. I don't know how to read this. دبستان بیرحمانه بسته شد بخاطر اون معلم رياضي. Hold up. You read this because your teacher, math teacher, recommended it? That's so cool. Code block. Much things do not apply to ML. Yeah. Ooh. This is a really long. Is there a summary? Favorites. Ooh. مدرس رياضي هستين. مدرس رياضي دارين. Yeah. I mean, if someone read it for me, I'd probably understand it better. The cover? Super ellipsis? I mean, it's supposed to be 0. Why would 0 be a circle? This here is actually a circle. Huh, there's a circular version? I'm not happy about that one, though. That's pretty. Why is the guy's name Charles Safi? I should not. Uh-oh. Someone's derailed. Is that a normal last name? Correct me if I'm wrong, but Safi, does it come from the word safe as in sword in Arabic? So that would be pretty cool if it is the case. Language models, right?
Now is that we are going to have an Expo 2. And this Expo 2 is going to be way multiplying Rx. So let's think this through. Way is T by T. And this is matrix multiplying in PyTorch a B by T by C. And it's giving us what shape. So PyTorch will come here and it will see that these shapes are not
different.
The same. So it will create a batch dimension here.
Oh.
And this is a batched matrix multiply.
I thought it's a normal matrix multiply where AB, CD becomes AD? Oh, no, wait, BC? I've forgotten everything. Hi. No, you don't need to catch up on anything, I promise. You can watch the video, though. Do not need to catch up. Safe is German for soap. Huh. Okay. You can always say it's sword in Arabic. Hi, welcome. Why apologize? Honestly, no need to apologize. Yes. Hi. Oh, wait. Trying to add the emoji, but I'm 2, 3, go. There we go.
And so it will apply this matrix multiplication in all the batch elements in parallel and individually. And then for each batch element, there will be a t by t multiplying t by c exactly as we had below. So this will now create b by t by c, and expo 2 will now become identical to expo. So we can see that torch.allClose of expo and expo 2 should be true. Now, so this kind of like convinces us that these are in fact the same. So expo and expo 2, if I just print them, okay, we're not going to be able to, okay, we're not going to be able to just stare it down, but, well, let me try expo basically just at the 0th element and expo 2 at the.
I always, oh my god, what happened to my voice? I always use, the website called Text Compare. Like, you can compare anything there. I like it. I'd probably do that.
The 0th element, so just the first batch, and we should see that this and that should be identical, which they are.
Cool.
Right? So what happened here? The trick is we were able to use batched matrix multiply to do this aggregation, really. And it's a weighted aggregation, and the weights are specified in this t by t array. And we're basically doing weighted sums. And these weighted sums are according to the weights inside here, that take on sort of this triangular form. And so that means that a token at the tth dimension will only get sort of information from the tokens preceding it. So that's exactly what we want.
Cool.
And finally, I would like.
Found this, not sure if it's true, German and Jewish, Ashkenazic, metonymic, occupational name for a soap maker. For Middle High German. Arabic variant of safe. Wait a minute. How is that supposed to mean? Hold up. Are they supposed to be related? Sorry, I am not. You don't have to. You don't have to dig deeper. But yeah. The thing about Arabic is, like, I'm gonna try and test something. Like, if I write scene, right, safe, there we go, safe. We get, okay, knife, blade. That's pretty similar. But if I write, there's a word that's supposed to have 50 different meanings depending on the context, and it's called ayn. Would ya look at this? Isn't that funny? It can mean, where's the thing that has to do with water? What? It's not even here? It's supposed to mean like, oh, ayn, the one that, I, yeah. Where is it? Tap is not supposed to be it, right? No. Anywho. What? Oh, jasus. This also has to do with spying. Yeah. Rescue. How? You tell me. Yeah. So, don't try I don't know. Like, I can't say it doesn't mean that thing in that Arabic because the word set. That's a good one. Yeah. Have a few dozen meanings. True. Yeah. Languages are cool. Human and non-human alike.
To rewrite it in one more way, and we're going to see why that's useful. So this is the third version, and it's also identical to the first and second. But let me talk through it. It uses softmax. So trill here is this matrix, lower triangular ones.
Yeah.
Way begins as all 0. Okay, so if I just print way in the beginning, it's all 0. Then I used masked fill.
Oh,
so what this is doing is...
So I was about to say, this doesn't have anything to do with masks, right? This trill.
Way.masked fill, it's all zeros, and I'm saying for all the elements where trill is equals 0, make them be negative infinity. So all the elements where trill is 0 will become negative.
All that and how you took in English so well. I'm not sure if you're aware, but I don't speak Arabic. I mean, I know Arabic. I'm not an Arabic native speaker. Yeah. Bunch of sources say set has. Wow, it does seem a bit dubious. I'm gonna just say 64, but yeah. I live in a country that's main language is Arabic, but yeah. What was I yeah. Oh. Nope, not English. No. It's a language similar to Arabic.
Negative infinity now. So this is what we get.
Negative infinity
Is softmax. So if I take a softmax along,
like if you Google what languages are spoken in Iraq, you'll definitely find it.
Every single, so dim is -1, so along every single row, if I do a softmax, what is that going to do? Well, softmax is also like a normalization operation, right? And so, spoiler alert, you get the exact same matrix.
Cool.
Let me bring back the softmax. And recall that in softmax, we're going to exponentiate every single one of these, and then we're going to divide by the sum. And so if we exponentiate every single element here, we're going to get a 1. And here we're going to get basically 0. 0, 0, 0, 0 everywhere else. And then when we...
freedictionary.com. Does it have... Is there an Arabic side? Of course I love Korean. I have been... How can you tell how many are there? Oh, there's a counting. Cool. Variant of Seth? Why? Hold up, let me use my brain. I like Korean because yeah, okay. This is English only, right? Ooh, hi. Okay, can we change to... no, I can't. I should. Let's try. I don't know. I really don't know. Uh-oh. Nope, I don't know. I'm trying to write Ein with my current keyboard, and I don't have the helper things on my keyboard. I will write it here. Ein. And then copy and paste it. And Let's see if this one. Oh, what happened? Huh? Does not exist? Oh well. That's weird. Anyway, something wrong. Yes. I love Korean. There we go. Because, yeah, I've been trying to learn it for like 14 years. I don't know Korean at all, but I do think Korean as a language sounds very nice. True. The thing that sort of surprises me is that, watching, I've noticed it for Japanese a lot more than Korean, but like your pitch and your tone and everything changes when you speak English and like, let's say Japanese. Yeah, I actually have tried making tteokbokki and kimbap. Yeah. Yeah. There is some humanitarian level support that the Korean people did for Iraq post 2003. So that's how I got introduced to Korean language and all of that. Tons of that's cool. Yeah, less so here, obviously, but yeah, people have a positive light. View Koreans in a positive light here because of the humanitarian support. So I'm not trying to like. I don't mean this in any way, but because I don't know why, like liking Korean entertainment nowadays is people look at you weird. I'm like, whatever. Yeah. I don't need to prove myself to anyone. I like K-pop, I like K-drama, so what? Sue me.
Normalize, we just get 1. Here we're going to get 1, 1, and then zeros.
Do let me know which food you like, or if you know the name of the food. Who doesn't love good ramen?
And then softmax will again divide, and this will give us 0.5, 0.5, and so on. And so this is also the same way to produce this mask. Now, the reason that this is a bit more interesting, and the reason we're going to end up using it in self-attention, is that these weights here begin with 0. And you can think of this as like an interaction strength, or like an affinity. So basically, it's telling us how much of each token from the past do we want to aggregate and average up. And then this line is saying tokens from the past cannot communicate. By setting them to negative infinity, we're saying that we will not aggregate anything from those tokens. And so basically, this then goes through softmax and through the weighted, and this is the aggregation through matrix.
That's so cool. Did you see that? It said view corrections, and it took me to corrections. Beats open AI drama. That's a good one. That's a good joke. I think liking Korean media is more popular than it has ever been. True. But liking anything out of the norm probably makes people at least curious. Yeah, I think liking K-pop has become so normal that people now see it in a bad light. I don't know. Yeah. Back in my day, 2009, I don't know. We could, there was internet, obviously, but yeah, we could watch stuff on Korea TV.
Application. And so what this is now is, you can think of these as, these zeros are currently just set by us to be 0. But a quick preview is that these affinities
get
between
updated?
the tokens are not going to be just constant at 0. They're going to be data dependent. These tokens are going to start looking at each other, and some tokens will find other tokens more or less interesting. And depending on what their values are, they're going to find each other interesting to different amounts. And I'm going to
Okay, depending on what their values are, they're going to find each other interesting in a different way is way too humanization on my part. Value actual value and not the values they hold near and dear to their hearts.
call those affinities, I think.
Mm.
And then here we are saying the future cannot communicate with the past. We're going to clamp them. And then when we normalize and sum, we're going to aggregate sort of their values depending on how interesting they find each other. And so that's the preview for self-attention. And basically, long story short from this entire section is that you can do weighted aggregations of your past elements by using matrix multiplication of a lower triangular fashion. And then the elements here in the lower triangular part are telling you how much of each element fuses into this position. So we're going to use this trick now to develop the self-attention block. So first, let's get some quick preliminaries out of the way.
No stream tomorrow. It is out of my hands.
First, the thing I'm kind of bothered by is that you see how we're passing in vocab size into the constructor? There's no need to do that because vocab size is already defined up top as a global variable. So there's no need to pass this stuff around. Next, what I want to do is I want to create like a level of indirection here where we don't directly go to the embedding for the logits, but instead we go through this intermediate phase because we're going to start making that bigger. So let me introduce a new variable, nembed. It's short for number of embedding dimensions. So nembed here will be, say, 32.
This one is a year old, but there's a very recent version that is, I guess, less than 2 weeks old. But this recent version is not, I mean, it's 4 hours long. It's not like it's not in detail, but it is a successor. So, you want me to send you the link just in case?
This is a suggestion from GitHub Copilot, by the way. It also suggested 32, which is a good number. So this is an embedding table and only 32 dimensional embeddings. So then here, this is not going to give us logits directly. Instead, this is going to give us token embeddings. That's what I'm going to call it. And then to go from the token embeddings to the logits, we're going to need a linear layer. So self.lm head, let's call it, short for language modeling head, is nlinear from nembed up to vocab size. And then when we swing over here, we're actually going to get the logits by exactly what the Copilot says.
Wow.
Now we have to be careful here because
that was
this
scary.
C and this C are not equal. This is nembed C and this is vocab size. So let's just say that nembed is equal to C. And then this just creates one spurious layer of indirection through a linear layer, but this should basically run. So we see that this
The talk part are giving me deja vu, as in you've seen it, because it's not new.
runs, and this currently looks kind of spurious, but we're going to build on top of this. Now, next up, so far we've taken these indices and we've encoded them based on the identity of the tokens inside IDX.
Why did it become night?
The next thing that people very often do is that we're not just encoding the identity of these tokens, but also their position. So we're going to have a second position embedding table here. So self.position embedding table is an embedding of block size by nembed.
If you cheat at following under Carpather's video, do you think he'd retreat you? I didn't. If we make Tiny Sherlock, I might, but I'm not doing anything like anything good. I'm just watching him be smart. Why would I? I don't think he's at that. I don't know. I don't think so. I mean, one must try and be shameless enough. And if we make our Tiny Sherlock, we can share it and say it's literally based on this, just a different data set.
And so each position from 0 to block size -1 will also get its own embedding vector.
Oh, I always reach out to people that I admire and think I can add some tiny value to their to them. Yeah, but I don't think I can add value to Andre Karpathy's life. Though I actually do want to be to reach out to researchers, because it has gotten into my head, let's say in a year's time, to apply to an online PhD. Like, I am done with trying locally. Long story, very long story.
And then here, first let me decode b by t from idx.shape. And then here we're also going to have a pos embedding, which is the positional embedding, and this is toward
I should try using Copilot. Like, I have not used Copilot.
Range. So this will be basically just integers from 0 to t minus 1. And all of those integers from 0 to t minus 1 get embedded through the table to create a t by c. And then here, this gets renamed to just say x, and x will be the addition of the token embeddings with the positional embeddings. And here the broadcasting note will work out. So b by t by c plus t by c. This gets right aligned, a new dimension of 1 gets added, and it gets broadcasted across batch. So at this point, x holds not just the token identities, but the positions at which these tokens occur. And this is currently not that useful because, of course, we just have a simple bigram model. So it doesn't matter if you're in the 5th position, the 2nd position, or wherever. It's all translation invariant at this stage. So this information currently wouldn't help. But as we work on the self-attention block, we'll see that this starts to matter.
Okay, huh? That's sweet. I was about to do that. I was not about to sleep. I was about to run what we have, but if we can't see an output...
So now we get the crux of self-attention. So this is probably...
If I cannot see the output, then why should I run it? I waited to see if we would be somewhere interesting, but I guess not, because I'm about to end today's stream. We got to the point of here. No? I mean, no, actually, we were... I suppose we didn't do that. We were here mostly. This one is probably what comes next. Oh wow, look, 1 hour. That's a lot. We could just model the model. How does one model the model? Oh, use the model? I'm using a different data set. And I mean, I could run the whole thing and see what happens. Should you try that? So that there's some sort of ooh, K and Q. I'm just going. Can we use it? Full finished code. Yay. Error on me? It's called it is called Cano, as in cannon. Cano, yes, correct. Let's run the whole thing. And then decode 2000. Okay. Should that take long? We have unique characters, train and test data loading. 1 head of self-attention, multiple head of self-attention in parallel, simple linear layer followed by non-linearity, modeled in 3D space. I mean, that would be cool if I knew how to do that. Transformer block, communication followed by computation. Bigram, super simple bigram. Training. Ooh, we're already here? Whoa. How many steps are we running it for? Where can I see how many steps we're running it for? Are we calling it anywhere? 2000. No, that's generation. Step. Can't see it. Oh, 5,000. 1 billion steps. Maybe. Okay, 5,000 is going to take a minute. Should I post the output later in somewhere in Discord? Because I need to run. So yeah, I won't be here tomorrow because loss went from 4.7 to 1.9. How cool is that? Validation loss. Wow, validation loss and training loss are very similar. We can still see what's happening. Yeah. So I don't know if I should continue this for Thursday and then start over with the assignment starting Friday. I don't know. Let's see. I still think that I need to finish this video before I can think about the assignment. So we can do that. And yeah. So today's Tuesday. Tomorrow there's no stream, but inshallah the day after there will be a stream, continuation of this hopefully. And if our Sherlock becomes too cool, we can put it on Twitter. And yeah. Do let me know if you need anything. Otherwise, I am going to end the stream in exactly 2 minutes. So I'm still around now. I don't think this will be done in exactly 2 minutes. So yeah. Ironic that study interrupts, not wow, brain. Yeah. Oh yeah, that ironic side. Yeah, I suppose. Yeah. Internet shut down because of exams. That's what happens. Even though it's not at the time of the exams, it's the prep time. So that questions don't get out, supposedly. But I mean, if there are or like work internet that are working, then is that a good thing? Studying interferes with exams. Sure. Like yeah. No, we're just like talking about my country that shuts down internet because we have exams. SAT level exams that are happening. Yeah. Well, my time's up. I will post this on Discord, inshallah, and see you the day after tomorrow. If there's anything needed, do let me know, whether it's on Discord, comments, wherever. I will do my best to get back to you if I can. Otherwise, catch me next time. See you next time. Thank you for being here. Honestly, I mean it. You don't have to. You really don't have to. I am doing this for me, and the fact that you're here is something that I appreciate. Okay. Goodbye. Sorry. Counting down in 5, 4, 3, 2, and 1. Thank you.